Right, hi guys. So 244, longish type question, but it seems that it, a lot of this question takes up. Once you've done it, you can just pick out the answers. That's the long bit. So you need to kind of take your time to read through what's really happening. As usual, please, you want to take time to have read the question carefully and not sort of rush into this video. Make sure, because I won't do it justice in terms of the reading. So you want to make sure you're taking your time to read it. We're looking at batches here. These people make things in batches. They give us some information about the individual units. They tell us you must satisfy this minimum daily demand. You can make as much as this, and this is what will determine your bottleneck. I mean, the question here is, whenever you can't make everything, the demand that's given to you, then that means there's a bottleneck. Right, that means that, so if you can't make all of this, the question is what's stopping us from making all of this in terms of maximum demand. That is what a bottleneck is. And when you have more than you need, then that's spare capacity. Okay, great. So you have this minimum you must meet. This is the individual. Now, if you remember this whole idea of ranking and dealing with throughput, we're only interested in throughput, which means we're only interested, if you like, in the selling price less the material cost. So in throughput, the only variable cost is material. That's the other thing you want to be happy with 100%. Okay, great. So they tell us what the processes are. These are the processes. So our first step really is to understand what the bottleneck is. Weighing, this is per batch. So you need 15 minutes to weigh a batch, and a batch, they tell us, has 40 units. So, if you're trying to hit 140, you must make them in batches of 40. You're going to have to make, you can't make half batches, so you're going to have to make 4 batches, right? Because here you can make 3 batches, and here you can make 5 batches. And that's kind of the picture. So let's see. Oops, sorry. Yeah, let's sort of see what's happening here. So we have a scenario here where it says the baking stage of the process is done. So they give us the total available minutes in terms of baking time. And you can see here it says ovens have a capacity of 1 batch per bake. Okay, so that's fine. You have a number of ovens. And it says you use throughput accounting to consider all costs. So we're talking about throughput contribution in effect. And then they tell us that on this particular day, so that's where we are. That's where we are. That's the information that we have right now. So let's look at this. So let's start. So it tells us on this particular day, you have the scenario where you have 240 minutes available for weighing and 180 minutes available for mixing, which is the bottleneck. So what we have to do, what you can see me do here, is I've put my spreadsheet together and I'm going to walk through that. So we have this batch size of 40, 30, 20. We have these selling prices here, and we have these all given to us already. Then I have the minimum daily demand, and I have the maximum daily demand. And what you can see I've done here is to work out the batches that I'm going to have to make based on, if I'm trying to hit 140, I'm going to have to make, and I'm making 40 each, I'm going to have to make four batches, and I have 3 batches here and 5 batches here. Okay, great. And the next question then becomes, well, okay, therefore, if I'm making 4 batches, how much weighing time does that take up? Well, that takes up, well, that's the information here, 15 minutes, and 20 minutes for weighing each of these batches. So what you see me do here is then say, okay, let me just take this step by step. So I'm going to start off with baking. So baking is 120 minutes for each batch. So for making the first thing here, which is brownies. So I'm making 4 batches. 4 batches, 120 minutes for each batch, will lead to 480 minutes for 4 batches, for all the batches. 110 minutes for 3 batches will lead to 330 minutes. And 120 minutes for each batch, and have 5 batches, will lead to 600 minutes, and that will lead to a total of 1,400 minutes. So it tells us we have 1,440 minutes. So we know this is in the bottleneck. We can make all the demand within the time that we have given. Weighing, I do exactly the same. So for weighing, I will need 15 minutes for each batch, so that's 15 times 4, which is what you can see there, 60. And I will need weighing 15 times 3, 45, and I will need 20 times 5, which is 100, and I need 205 minutes. And I think I'm told that I have 240 minutes there, right? The problem is mixing. Mixing, I need 20 minutes for each batch, and that's 80. I need 16 minutes for each batch, and that's 48. And I need 12 minutes for each batch, and that's 60. And that total comes to 188, but I only have 180 minutes. So my bottleneck is B, mixing. I need 188 minutes to get this all done. I only have 180. Whatever, machine breakdown, people aren't around. That's the problem there. Okay, great. Let's carry on. So, question 2. So this is where the work is. There's a lot of work here, but it's not a lot per se. It's just once you get it done. It says that the mixing process is identified as the bottleneck. We only have 120. What should we do to maximize? So you're thinking, okay, let's go in there. I have to make, the first thing I need to do is first of all work out what is my throughput first. What's the throughput? So the throughput, let's find this is selling price is 1.5, material is 0.25, so therefore the throughput, first of all, the throughput, I should put throughput here, is this basically the selling price minus the material cost. That's all I'm interested in. And you're making there are 40 units in a batch, so the total throughput for each batch is 50, which is 1.25 times the number of units in a batch. So that's the total throughput, if you like, or the total contribution from each batch of brownies, each batch of muffins, and each batch of cupcakes. And in terms of mixing time, it takes you 20 minutes to mix a batch, 16 minutes, and 12. So therefore I can find the contribution per minute of mixing time. And in this occasion, cupcakes has the highest mixing contribution per mixing time, and that's what I'm going to make first. You have to, first of all, you have this minimum demand of 30, 20, and 10 from the local cafe. We've been told about that. And you make in batches of 40, 30, and 20. You cannot just make the 30, 20, and 10 because that's not how they're made. They're made in batches of when they're put in the oven. So you have to make this first. That's what you make. You have to follow the rules. So making that's what you have to do. And the question is, how much mixing time do you need for this very first minimum demand? Well, for each batch you need 20, they tell us 20 minutes, 16, and 12. So that's 48. It tells us you only have 120. So you can see here that if you only have 120, that's what I'm doing over there. These two things are equal to 120. If you only have 120 and you've already used 48 for your minimum batch, you only have 72 minutes left. So let's carry on. So what do we do with these 72 minutes? Well, it tells me to make all of the cupcakes. So if I'm going to make an additional 4 batches of cupcake, because the demand is for 100, each batch is 20, so I make another 4. Well, I will need 4 times the mixing time of 12, right? Of 12, which is 48 minutes. So that's another 48 minutes gone. So it means you now have 72 minus 48, which is only 24 minutes left. And really, if you're going to make, the next thing to make are brownies, and it takes you 20 minutes to make a brownie. So you can only really make one more batch of brownie for that 20 minutes. So in essence, what can you make? Well, you can only make 5. You can make 5 batches of cupcakes. You can make 2 batches of brownies, and you can just make the 1 batch of the muffins that you made for the client who you must make. So that's 100. 2 there. That's 80 because you make 40 in each, and that's 30, I believe, yes, for each, because that's what you can do. So your answer there comes to A. So a bit slightly long-winded, but doable if you just take your time to read it, and which is what I'm sure you're doing to make sure you're understanding what's going on. Okay, right. So let's let's see what's going on here. Sweet Treats Bakery has done a detailed review. So TPAR, if you remember TPAR, what we're doing TPAR, let me just go to a word. Let me just go here. Just go to a blank document very quickly so I can write. Right. I'm sure you're revising this very clearly a lot, please, before you're coming here. TPAR. Oops. TPAR. Well, that's disappearing as I'm writing. Very interesting. I've not seen that before. Okay, what's going on? Oh, it's come back. TPAR is equal to, if you like, the throughput per whatever the hour is of what we're dealing with, of the restriction, divided by the factory cost per hour. So we're literally comparing throughput to throughput or revenue, if you like, to cost. That's what's really happening here. Throughput per hour divided by factory per hour, factory cost per hour. So throughput, remember, was the selling price minus the materials, and then factory is everything else. So really, this is almost like a math question. If we're trying to improve this, we want to improve revenue. Anything that improves revenue improves the numerator. Anything that decreases the factory costs improves the throughput. We want this greater than 1 because it means that this is greater than the revenues are greater than costs. So let's go back to the question. It says, which of the following will improve the throughput? So the cafe customers will be given a loyalty discount. Well, this will decrease your revenue, so this will not improve that ratio, right? That won't improve it. A bulk discount on flour and sugar, that will reduce the material cost, so that will improve your revenue, the numerator. There's additional demand for the cupcakes. There's a demand. We're trying to improve margins, so unless there's an increase in price, that will not improve your scenario here. So this will not, this will not, and the rent has been reduced. Well, that reduces the factory costs, the denominator, so that will improve your TPAR. Great, and that's number 3. So again, please, you just go over TPAR very quickly. Yes. Right, and then let's quickly get through 4. Let's get through 4. Let's get through 4 and 5 very quickly. Yes, so here we are at question 4. So question 4 says to us that there's a local food festival. I'm sure you've read this. It says that you're thinking of hiring another identical oven just to deal with cupcakes. Now just look at this carefully, just to sort of see the scenario. Let's go back here. Your contribution on a batch of cupcakes is £35. I'm just going to give that a different color now. £35. That's what you're getting on each batch. It tells you that you want to bring in another oven. Each oven is 8. You have 8 hours in the day. And you know that it tells you that you have 120 minutes. It tells you you have enough time for mixing and weighing, but the oven can only work for 8 hours a day, and it takes you 2 hours, basically, to bake a batch. So you can make 4 batches of cupcake, ultimately. So if you can make 4 batches of cupcake, that's 4 times 35. 140 potential contribution coming in, less this additional cost you will have to now pay, which is 140, minus the £45 that you're told that you will have to pay to hire in this new oven, which gives you a profit of 95. So your answer there is C. Again, oops. So that's C. And then finally, it says here that, yes, here we are. So we're trying to improve, again, kind of similar to what we were doing earlier on. I think we can sort of come here and look at this one. What we're trying to say here is that TPAR, again, is this relationship between throughput at the top and factory costs. Okay, great. So, which is correct. So, I think sorry, I've cut out the top bit. We found out that weighing was a bottleneck. So weighing is stopping us from moving as fast as we can. So it says the bakery's operating, so in terms of throughput, the bakery's operating costs, which is what's happening here, exceeded the total. It tells us it was 1.45. So this was greater. This is 1.45 and this is 1, if you like. It tells us that operating costs were greater than the total throughput contribution generated from its 3 products. No, that's false, because you can see here this is greater than this. This is great. So this is not even true. So this is wrong anyway. Less idle time in the mixing department will improve TPAR. No. The whole idea here is that the bottleneck is with weighing. We need to make things better with weighing. That's the only way we're going to improve throughput. Right? Do everything else, improve other things, but no. If you have a bottleneck with mixing, with weighing, then you have a problem. And improved efficiency during the weighing, yes, will improve, because that will definitely lead to that would lead to not material, but that would lead to lower factory costs, if you like, and therefore we would improve our overall TPAR. So the focus with TPAR is always the focus on well, there's 2 things actually: the ratio itself, the fact that this must be greater than this, and also the fact that the bottleneck, you cannot do better until you fix the bottleneck. Improve the other areas, nothing will happen until you fix the bottleneck. So the answer here is A. Cool, great stuff. See you in the next question.